Hey, welcome everybody. Welcome to our live stream today. My name is Stu Shader and I'll be your host. I'm part of the NGINX business unit here at F5. Today's session is called From Zero to Production in Kubernetes, Deploying an Ingress Controller with Pulumi. I'm super excited to be here today. Little background to get you started before I introduce folks about what we're going to be talking about first. Setting up your production Kubernetes environment brings many benefits, as you know, including scalability, portability for your applications. But before you reach production, it's super important to understand the key Kubernetes concepts and architectures available to keep your clusters secure and scalable. Ingress controllers are vital parts of any Kubernetes platform, and our Ingress controller provides the best in class for traffic management, and especially for all your cloud-native apps and containerized environments. We are so happy to have two experts here today to talk about this. I'd like to start off by introducing Lee Briggs. Lee is a developer advocate at Pulumi. He has about 10 years of experience designing, building, maintaining distributed and complex systems, and he wears those scars of the many different deployment tools that are out there. When he's not trying to fit a monolithic application into a container, he loves to play soccer. He loves to watch soccer. He loves to take hikes and walk with his family, and he especially loves his dog Cindy, who might make an appearance later. We also have Elijah Zubankic. Elijah is a buddy of mine from F5 and NGINX. He's a solution architect. He has tons of experience as a software engineer, as an architect, and a technical manager. He's been in the past leading software teams in architectural design, product development, and holistic improvement for over 10 years. And he loves to geek out on infrastructure, architecture, application composition, service design, and even psychology of making real world applications work. Elijah, you're going to kick it off with a short interview of NGINX today. Would you like to take the helm here?
Absolutely. Thanks for that intro, Stu. So kind of before we start, I wanted to set the table with just defining some concepts, some terminologies, and let's just start with NGINX, right? I imagine most of everyone listening is familiar with NGINX. It's deployed to over 4 million sites right now. So pretty common brand, but for those who aren't familiar, NGINX was originally designed as a performance-optimized web server, and then over time, features were added, and it grew into a reverse proxy and load balancer, API gateway, and cache. In terms of NGINX's design principles, we prioritize stability, security, and customizability. Those are the trade-offs we've chosen. And so you'll see that those themes reflected as we talk about the NGINX Kubernetes Ingress controller. So all that said, every month we're adding new features to NGINX. And for about the past decade, we've been right in the middle of the development of the modern web and have participated in the creation of a lot of core technologies like HTTP2. Really, NGINX is the standard in which you judge reverse proxies now. So with that said, let's move on. So what is a Kubernetes Ingress controller? Well, basically, it's a construct within Kubernetes that allows you to define a reverse proxy that gives access to backend services within Kubernetes. This construct I find useful because it allows you to load balance across multiple backend instances and to define middleware logic that you use to transform the request or the response from your services. It looks something like this. Okay, so that's kind of a super high level. It's just the interface. An ingress controller is this abstract concept of something that can be plugged into Kubernetes. So there's many open source projects out there that provide ingress controller support to Kubernetes. The default choice is the community-led NGINX Ingress controller, which we'll call the community version for short. I'm going to drop a link in here if it'll let me. Let's see here. Okay, it's not working for me, but we'll share the links later. You can find it on GitHub under the Kubernetes project, Ingress NGINX. There is also the NGINX official Ingress controller, and that's what we'll be introducing in this presentation. So just like NGINX itself, the NGINX Ingress controller project prioritizes the design principles of stability, security, and performance, as well as customizability, whereas the community edition prioritizes more exploratory feature development and kind of more just kind of bleeding edge integration of features. Unfortunately, the two editions are not compatible right now. So if you have annotations in the community edition, they don't just port over to the NGINX Ingress controller. Okay, so what does all this mean? Well, this means that NGINX has spent a lot of time creating an Ingress controller optimized for production workloads. As part of this, we've optimized for small container image sizes, low latency reconfigs, few to no timeouts, a proactive approach to security where we respond to CVEs quicker than other projects generally. Also, the level of customization is much deeper. It's a bit out of scope of this conversation, but you can really customize nearly all the aspects of the way NGINX runs in Kubernetes as an Ingress controller using a construct that's called the virtual server configuration context. This is different than the general Ingress configuration context that we'll be showing, but I just wanted to call it out because you can customize nearly everything, and that's not true in the community edition. Additionally, you can add functionality like web application firewalls and service mesh integration, as well as you can easily customize the runtime image that you're using a kind of a simple make build operation if you check out the Ingress controller's GitHub project. So there's a lot of knobs and dials available for you to fiddle with, and I encourage everyone to explore it. Okay, I know that was a lot, but I hope it clarifies a little bit as to why you would want to use NGINX as your Ingress controller, and basically set the table of like, why are we using Pulumi to orchestrate Ingress controllers in the first place? Okay, Lee, did that?
Yeah, that's great. Thanks so much, Elijah. I will just say I'm having a few internet problems at the moment that I got a notification from my internet service provider. So if you do hear me be choppy, I do apologize. It does seem to be coming in and out in waves if you are watching live. Thanks very much, Elijah. I'm Lee. I'm from Pulumi. Thanks very much, Stu, for introducing us. I'm just going to go through a few more slides, and then we're going to do an exciting demo to give you an idea of the kind of things we're talking about. So Pulumi is an infrastructure as code platform that is a little bit different to many of the infrastructure as code platform, infrastructure as code tools that you might be familiar with. And what's interesting about it is that it uses the familiar programming languages that you are using in your application development lifecycle. So, you know, every organization has to ship products and applications, even if you are a, we have customers that are not really in the tech sector that still have to, ship applications. And often when you're actually trying to do infrastructure as code practices, you're often having to chop and change between languages and sometimes even configuration formats, which can be a real jarring experience, certainly for your software developers during their infrastructure lifecycle. So Pulumi is different. It uses the programming languages that you're already using to actually define that infrastructure. And what we think about this is that it means that your infrastructure as code can be now for the entire cloud engineering organization. So if you have a team of front-end developers who are writing things in JavaScript and TypeScript, they can use that same programming language to define their infrastructure to deploy their applications as well. We like to call it infrastructure as software rather than infrastructure as code, because, of course, you are following all the software engineering practices that you are used to already within your organization. If you are an infrastructure engineer, you're already using these kind of things because you're probably helping with build and release pipelines. So you're already familiar with things like dependency management for these software outlets, for these languages. And if you're a software engineer, you're already using them to build your application. So now you can also use those same things to actually deploy your infrastructure. We currently support 4 language ecosystems. We're going to be looking at Python today, but you are free to kind of chop and change between these languages as you see fit within your organization. So again, you can use Pulumi with Node.js, using JavaScript and TypeScript. If you have a backend service written in Go, you can use our Go SDK. If you're a .NET shop and you're writing things in C# or F# or even Visual Basic .NET, I have a blog post on my blog right now where I enjoy deploying things to Kubernetes with Visual Basic .NET, if that's the kind of thing you enjoy doing. But as I mentioned, we're going to be looking at the Python SDK today, and looking at how that can make it much easier for you to not only deploy your NGINX Ingress controller to your Kubernetes cluster, but also then use the Ingress resources and use the some of the configuration options that Elijah already mentioned, and actually propagate those things through your infrastructure as code. What I don't have time to talk about today, but I wish I did have time, is we're going to show you a mechanism of deploying infrastructure code kind of in a traditional kind of tooling way. So I'm going to show you the Pulumi command line. I'm going to show you interacting with like the actual Pulumi SDKs. But what's super unique about Pulumi in particular is that because it is using these software engineering languages like Python and Go and .NET, you can actually build your own kind of deployment platforms and pipelines using our automation API. If you do want to know more about this, then I am on Twitter @BricksL, and I'd love to talk to you about it. And what I'll do towards the end of the demo is talk a little bit about how you might use some of the things I'm going to show you inside new mechanisms to get things into the hands of your developers and your organization. So that's a lot of talking. We've shown you a lot of slides. I think what everybody really wants to see is a little bit about what this looks like in action. So I am going to change my screens over. If you do want to follow along at home, all of this stuff is checked into GitHub. The link should be scrolling across your screen any minute now. And there's a couple things that I've actually done here. Before this, I deployed a Kubernetes cluster in Amazon AWS and Amazon Web Services using our TypeScript SDK. So I provisioned a VPC, and then I provisioned an Amazon EKS cluster, which is ready to have a NGINX Ingress controller deployed to it. And there's a couple things that you might want to be kind of aware of here, especially with Amazon EKS. You need to make sure that the subnets that you're going to actually use are tagged correctly. If you are familiar with EKS and using Ingress controllers, this might be something that you've already kind of noticed. And Pulumi makes this super easy. And if you are a TypeScript software engineer, this probably looks pretty familiar to you. It's just standard TypeScript. And then I've deployed the actual Kubernetes cluster using that. So what does that look like? I'm just going to go back to my info.
Let me pause here a moment. So I'm just making sure I understand this right. We've defined an entire Kubernetes cluster in TypeScript.
That's right. Yes. An entire VPC, a best practice VPC with public and private subnets, so that we can keep that separation of network concerns. And I've also defined a best practice EKS cluster. I've made it pretty small because I don't want to, waste my employers' hard-earned dollars. And I've just deployed a couple of nodes. But yes, this provisions many resources. So it's provisioning both a VPC and a cluster inside that VPC. And you can notice if you kind of take a look at this, and again, this is TypeScript rather than Python that we talked about, but you notice that we can actually pass the results of provisioning a VPC, and we can pass the private subnets and the public subnets directly to the EKS cluster. And awesome. This is around 65 lines of TypeScript. And if I take a look at the actual deployment of the cluster, obviously this has already been deployed. Pulumi, despite being written in TypeScript, it drives towards a desired state. So you'll notice that it's got 61 resources here that I've deployed, and because I haven't changed anything, it isn't actually going to make any changes. And I can take a look at the details here. And if there was any changes, it would show me all of the differences that are happening. And when we kind of look at the NGINX Ingress part of this, it will start to make a little bit of sense. So, that's the kind of setup that I've done, the preparation to try and get it ready.
I didn't see any YAML soup.
Well, so there is actually a tiny little bit of YAML, but the only YAML is actually in the Pulumi project itself. So here you can see that we've actually set a name for our project. We're going to tell Pulumi what type of runtime we're actually going to use. So this is the Python code we're going to look at in a minute. And that's all the YAML that you will ever need, basically. Speaking of YAML, we've deployed our Kubernetes cluster. The next step for most organizations is that they actually want to start deploying their applications. So I pulled this from your examples, from your NGINX examples. This is the cafe example that comes from the NGINX demos. This is probably what most people are going to actually see when they're deploying things to Kubernetes. So you define a deployment, you define a service, and then you define your all-important ingress object, which is what NGINX Ingress actually takes care of. And you can see that I can define a host and all that kind of stuff. And I've set my service name. And obviously what this would look like in a normal environment is I would do kubectl apply -f cafe, and it would deploy my application. And, I'm very happy because my application has been deployed. And you'll notice that I actually tested it out earlier. So all of these things are unchanged. This is a great workflow. Like Kubernetes, I'm a huge believer in Kubernetes really enabling organizations to be able to, actually be productive when they're creating applications. But this is only a single application. And if I actually want to deploy another application, I'm going to have to go back to my YAML and start to update all this. So let's say I wanted to deploy something called T. I'm going to have to go through, I'm going to have to manually update all this stuff. And it can even be the same instance of the same application. But if I want to update any of this stuff, it's going to be a really painful experience, right? Like if I wanted to call this, update the host or anything like that, I'm going to have to kind of go through here and kind of do this. And there are mechanisms out there within YAML to actually kind of make your life a little bit easier, but they generally involve templating that YAML. So you would usually have some kind of environment variable, or you would use something like Helm, and it ends up looking a little bit like this in here, and it's error prone if you don't escape the YAML properly. Like, if I actually try and apply this right now to the cluster, it's going to tell me that there is a problem, and I'm like, okay, what the hell does this error message mean? I don't really understand what's happening here. Which, of course, really from a user-friendly perspective, like I can imagine most people watching along at home have thought, yeah, okay, I can see where this is painful, but I can muddle through this. I can kind of get this, I can get this working. But the problem that really comes up is that, a lot of software engineers that need to deploy things to Kubernetes and start creating ingress objects with NGINX, they're already familiar with certain languages that they're already using in their software development lifecycle. So, why do they need to learn this archaic shell escaping, templating language type stuff? So, what's the alternative? Well, I personally believe, and I understand that I'm an employee of Pulumi, but before I was an employee of Pulumi, I firmly believe that kind of providing infrastructure as code interfaces to your users in languages that they understand really makes things much easier for them to actually help you and contribute to your overall environment. So what we want to do, first of all, is actually get the NGINX Ingress controller installed into our Kubernetes cluster. So what I've done here is I've used our Python SDK to define a couple of things that are important for NGINX Ingress. I've defined a namespace here. in Python, which I'm calling NGINX Ingress. And then I'm using the Helm chart that you at NGINX are very happily providing to us, that I can install directly from your Helm chart repository. And I can set all of the values that I actually need. I do not have an NGINX Plus license with me right now, but if I did, I would probably set this to true, again, which is just a standard Python Boolean value. And this will deploy a NGINX Ingress controller into my Kubernetes cluster, and it includes all of the things that you might need in an NGINX Ingress controller. So it will satisfy Ingress objects within NGINX, but it also includes all of the awesome things that are part of NGINX Ingress, like virtual server resources and all the other stuff, which I think, Elijah, we're going to talk about in a future live stream, which I'm really excited about. So what does this look like? Let's take a look at what this looks like deploying an NGINX Ingress controller with Pulumi. So I'm going to use my Pulumi up command, which will tell me that it is going to deploy a bunch of stuff. So you can see it's going to create the namespace here, and then it's going to create the chart. And then as a sub-resource of that chart object, you can see that all of these things that are kind of part of the nginx.com Ingress controller are going to be installed in my cluster. So you can see transport servers, policy servers, virtual server routes, virtual servers, and we're going to talk about all these in a future live stream. It will also install the Ingress class, which we'll talk a little bit more about in a second. And then it's also going to install the actual controller. It's going to install the actual controller, which will actually satisfy those Ingress objects. If we scroll back up a little bit, you'll notice that when I deployed using the YAML, I'd already kind of deployed it, so it just told me that things were unchanged, but it didn't give me any actual information about what happened when I deployed these things. I would have had to kind of look at the logs and look at the deployment status and run a bunch of commands. And if you imagine if you're in a CI/CD pipeline, which is obviously a best practice production way of deploying things, you probably want a little bit more feedback about what's actually happening with your super important production deployment of an Ingress controller. So let's have a look at what Pulumi provides us when we do this. So it's going to start creating a bunch of resources now. And you can see it's creating the Helm chart, and it's creating a bunch of different resources, and you can see the order in these things that are happening. So Pulumi's taking care of, providing me with a bunch of information. I'm just going to zoom out a little bit so that we can actually see. If you take a look here, you'll notice that Pulumi is actually kind of helping us with the deployment of this Ingress controller and making sure that the pods are actually becoming healthy when you deploy it. So it's actually taking care of, it's making sure that all of the different parts of the deployment are successful. So you can see here, we currently don't have enough replicas that are successfully created. So the deployment will continue. And there is our creation event that's finished there. And it's telling us that the actual Ingress controller is now up and healthy. And there we go. We've deployed an Ingress controller, and we've got way more feedback from our actual infrastructure tooling telling us that this is now a successful and healthy deployment. So if there was a problem with the code that I'd written, and it wouldn't be the first time if I had some problematic code in my life, if there was a problem with some of the code that I'd written, Pulumi would have told us, hey, you know what, your Ingress controller hasn't come up, it's not healthy. It would give us that feedback during that process, which, for me as a kind of infrastructure software developer is really, really valuable to be able to see, during the deployment pipeline. And you can also notice, because I made my Kubernetes cluster a little bit smaller than average, it's actually telling us that, some of the requests that we actually made are being throttled by the API server because we're making a bunch of requests at the same time. So I can also probably get some feedback here and think, oh, I probably need to make this cluster just a little bit bigger. So that's the kind of actual deployment of the controller itself. And I'm just going to zoom in a little bit more so everybody at home can see. And I can validate this using standard kubectl commands. So I can look at kubectl get pods -n nginx ingress. And you can see my Ingress controller is running. And I might want to look at the logs of this. So let's have a look at the logs. And here is our NGINX Ingress controller is up and running, and we're actually getting the logs that are telling us, okay, everything's good, but I have nothing to do right now because you haven't actually deployed an application that deploys any Ingress objects. So the NGINX Ingress controller is just happily sat there, just kind of waiting for me to tell it to do something, which is where we get to the stage where I think it's really important to talk about the kind of user interface again. So again, if we look at our old example of our Ingress object here that I showed you with our kind of a traditional YAML mechanism, this is the point in your kind of deployment pipeline where your users would start to say, hey, I've got this application, I want to put it in our Kubernetes cluster, and I want to put it behind the NGINX Ingress controller, and I have a bunch of security things that I need to actually add to it. So how do I do that? And you might, as a user, you might hand over an example YAML template and say, hey, look at this, and just kind of figure out the little bits and pieces that you want to use. That's one way to do it. It's a way that a lot of organizations are very successful with, but we believe at Pulumi there's a better way here. And what we think is the better way is using the kind of the IDEs and the software development environments that you're already used to. So what I've done before in the GitHub repo, if you take a look in the GitHub repo, it's all in here in the in this directory, in this NGINX Ingress directory. I have defined what we call at Pulumi a component which simulates a production-ready application, right? And so you at your organization know what a production-ready application looks like. You might think that a production-ready application has a single replica. I don't necessarily agree with you, but you might be okay with that. You know what the domains that you're actually going to pass to your NGINX Ingress controller. You know what they need to be. And you also know that your applications are going to run on certain ports and all that kind of stuff. So using the Pulumi Python SDK, I have defined a component, and this is obviously quite a few lines of code initially. This component is reusable. So you can give it, or you can kind of pass it to your users. You can perhaps publish it to PyPy, the Python Package Manager repository, and you can just allow your users to consume this using pip. Using the installer, the Python pip installer mechanisms that you are already using for your software development lifecycle. So you can see I've defined a namespace here. Like every application in our hypothetical production-ready application, every application needs to be in its own namespace. So I've defined a namespace within Kubernetes. I've also defined a deployment. And if you're kind of familiar with the YAML already, you'll remember earlier, if I scroll back to the error that we had earlier, you'll remember here that I tried to deploy this YAML and I made a mistake, an intentional mistake, but I made a mistake. I got this invalid value. So when you take a look at this kind of Pulumi Python SDK, you'll notice that we're actually using Python types on all parts of the actual specification of our Kubernetes application. So you can see that in my IDE, I can actually look at the definition of this, and it will tell me the different inputs that I'm allowed to use. And what this means is that when you're actually deploying these applications, you make way less mistakes. Because you're actually defining the Kubernetes application in a way that meets the required specifications for when you're deploying things. And this gets really useful when we kind of scroll down to our Ingress object, right? Because we know that we know that we need to specify a host name so that NGINX Ingress can do its reverse proxy job. And we know that we need to specify a path because that's how NGINX Ingress decides where it's going to actually route the application requests to. But by using these strongly typed mechanisms, by using these type systems within our languages, we can really help you as a user defining your infrastructure, make less mistakes, be more production ready, and get things to your users in a much quicker way.
Well, let me highlight right there, like where the host name is. Because this is all code, you could be pulling that data from anywhere that Python understands, any Python library, backend system, any sort of integration or dependency. Before you had to template a bunch of YAML, make your calls do it in some program and then put it into your templating system. Here, it can be all one sensible program that it's easy to grok and has some sensible organization, and you can version it.
Absolute versioning, I think, is a really, really key point there. And I'm going to talk a little bit more about that as I kind of show you how this works. But versioning, I think, is going to come back into the conversation in a few more moments, because you're able to actually kind of have more confidence and more happiness in your deployments than you are previously, because of the because of the kind of software development lifecycle that you're already using for your application, and now you can do it for your infrastructure too. So there's one other thing that I wanted to highlight here before I kind of do the deployment. If we go back to our YAML example, and actually I probably want to be here. If we go back to our YAML example, right? You remember that we have to specify an actual host name, an actual DNS record that we're going to specify with our with our NGINX Ingress controller, because NGINX Ingress will actually satisfy you kind of will do the reverse proxy work of actually getting you to your application inside your Kubernetes cluster, but it can't help you with the DNS part, because you actually need to register a DNS record, and you actually need the right host headers when you are specifying, when you're kind of looking at your application. So if you think about, if you're kind of following along at home, if you think about how that looks in other, infrastructure as code tools, you're probably going to have to use another tool here. And I know that there are things that you can deploy into your Kubernetes cluster, like external DNS, which will automatically resolve DNS records for you, which I think is great. But in this particular example, I wanted to highlight this because I can also actually specify a DNS record to pass to my deployment during the same deployment within Kubernetes. So you'll notice I'm actually using two different Pulumi providers here. I've decided to specify my AWS, my A records in AWS Route 53. So I can, in the same workload, provision a Kubernetes namespace, a Kubernetes deployment, a Kubernetes service, and a Kubernetes ingress, and also specify an A record that I'm actually passing to my application, so that I'm ready to go within my actual deployment of my application. It's all happening in the same place. I don't have to worry about kind of grabbing the value of the load balancer. Like if we look at our Kubernetes cluster, I'm just going to clear all this out. kubectl get service minus NGINX Ingress. Like NGINX Ingress within Kubernetes is actually provisioned an elastic load balancer for us. So when we deploy our application, we need to point a DNS record at this load balancer so that it can actually get through to NGINX Ingress, and actually the NGINX Ingress can do its job. And again, I think the point I'm trying to make here is you would usually have to either populate this DNS record manually, you'd have to use a third-party tool like external DNS deployed within your cluster, or you would have to pass it off to another infrastructure as code tool, because your Kubernetes YAML isn't capable of doing this. And all of a sudden, you can see the sprawl that's happening within your kind of like footprint. You can see that, a user who is just trying to get their application into your Kubernetes cluster, they already now have to know an extra tool or an extra mechanism to actually get the, actually get NGINX Ingress to do its job within the cluster. So, obviously, Pulumi has a solution for this, and we can just define it all in the same kind of production-ready application component that I've defined. I'm going to pause there. You got any questions, Elijah? I've kind of rattled through quite a few concepts here.
Let me get this last part right. Because you were able to do that entire Kubernetes deployment in Pulumi and get the result of the AWS ELB domain right out of the deployment, you can take that and then make that a CNAME for a domain, and then the site can just go live. You basically did Pulumi up, and now your site's live.
Exactly, yes, that's exactly right. And you can see me doing this here. I'm using get resource from our Helm chart to actually grab the load balancer address that NGINX Ingress, when it was deployed, as provisioned for us. And I can just pass this around as a value within my code. It's really, really easy to do. So how about we take a look at what that looks like and see what the results are.
Yeah.
So you can see at the top of my code here, I've imported in traditional Python way, I've imported my production ready application app and application arguments that I pass to it, because no matter how well you define a production ready application in code, it's probably going to need to be configured a little bit. Like not every application is the same. And so I've imported that into my actual program here. And you can see I can do it within the same program if I want that I'm actually deploying my NGINX Ingress controller in. So I've deployed the namespace, blah, 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 blah. And here I'm going to uncomment this line here. Here I'm actually going to specify the actual application that I want to deploy. And so I'm using the really helpful QA example application that's from the Kubernetes workshop because it's a really great example demo. But of course, I could specify any image I want in here, and I can do this over and over and over again. I can use this library many, many times. So what I'm passing to my production ready application is just the image, which is a required what we call input here. So the image needs to be specified to our production ready application. And then I also need to specify the load balancer address because the actual application doesn't know that. So as I mentioned earlier, I've actually grabbed this from the Helm chart deployment and I'm going to pass it here. So you can see this is just standard Python. I've created a variable. I've assigned that variable a value. Which is the host name that we get from the actual NGINX Ingress controller deployment. And then I can use that variable and pass it around in code super, super easily. So if you think about what this would look like in terms of like YAML templating, I might be doing a bunch of copying and pasting at this point. And that's a really painful exercise. And I have personally made mistakes doing that many, many times during my previous roles before I worked at Pulumi. So, you know, kind of seeing how to do this in this way was just really, really magical. And let's take a look what this looks like. So I'm just going to make this a little bit bigger. I'm going to run my Pulumi up again. And remember, this is the same program. So I've deployed my NGINX Ingress controller already. So all it's going to do is deploy the new parts that I have changed. And you'll notice it's going to create our namespace. It's going to create our service. It's going to create our ingress. It's going to create our ingress here. Create our deployment and create our ingress, which of course is what the actual nginx.com ingress controller is actually going to take care of. And of course, that magical AWS record here is all done. And of course, I've defined a lot of lines of code here in my library, but the actual usage of that is a single line of Python. And it's going to deploy all of these different resources. You know, it's going to create 6 new resources. It's not going to touch the things that I've already deployed because I haven't changed anything. And let's go ahead and deploy it. And you could see I did a bunch of demos. This worked 32 times before this, 31 times before this. So if it doesn't work now, the live demo gods obviously hate me. So it's going to create our service. And again, you get that same ability within Pulumi to actually get healthy deployments that have created. And you can see it's now creating our AWS Route 53 record. And of course, DNS, it's always DNS, isn't it? Like there's always a DNS problem. And any minute now when that has actually finished creating, I bet I haven't set my AWS profile properly, and this is probably going to fail.
Well, but there's a key point here I want to highlight that might not be obvious, and that is, you know, we've been talking about managing all this YAML, but sometimes you need these things you're managing with YAML to talk to things that aren't YAML, that are just HTTP APIs, JSON payloads, SOAP, gosh knows what. In this case, it happens to be the Route 53 API, and you're able to bridge those with right there in Python.
Yeah.
2 entirely different constructs, your Kubernetes deployment and your DNS record management, all there, seamless in an abstraction.
Absolutely, yeah. And again, like the user interface for this, for the people that you are, you know, if you're one of those organizations that's building a Kubernetes platform and is trying to make it easier for your users to deploy things, the actual user interface for this is not only the language they already know, but it's a single line of code. Like you've done all the hard work for them, and you've got these reusable components that you can just specify and, you know, pass around. And I just want to kind of reiterate as well. I'm going to rerun a Pulumi up here. Again, like this is driving towards a desired state. So, you know, if you think about, oh, I could probably do this with the AWS AWS Boto 3 mechanism. Like, you have to build all the state management in there yourself. Pulumi takes care of this all for you. So, we've deployed a production ready application. And again, like NGINX Ingress, if I take a look at the actual NGINX controller logs, you should be able to see, you'll see that it's created a different, an Ingress object, and you can see that here. That's the configuration for QA. My actual deployment has been added, and the logs have kind of updated there. So if you think about how that works on the back end, NGINX Ingress has kind of created a virtual host for you, and we should be able to visit this URL now and be able to actually look at it. But instead of looking it up, instead of actually, I know what the URL is because I specified it, but we can also export these values within our program as well. So I'm just going to uncomment this Pulumi.export here. I'm going to rerun my Pulumi up. And of course, there should be no changes because I've not actually made any changes to my Ingress object, but it's going to tell me that my URL is QA, and I should be able to go to, should probably copy and paste it. That'll help. There we go. I should be able to go here. Our application is in production. It's completed. It's actually done all the things that we want it to do. And I think this is a really powerful mechanism to be able to kind of actually get things into production super easily. And I'm actually hoping that nobody is going to hack my Kubernetes cluster right now. If you are watching at home, I will be tearing this down any minute now. But you at home can kind of visit this URL and verify for yourself that this created a Route 53 record and did all that kind of stuff. But there's just one final thing that I think we should just kind of talk about, right? And I'm coming back to the versioning thing, Elijah, that you mentioned earlier. The definition of a production ready application will change over time. Within your organization. So when you're creating these, different libraries that you might be, these components that you're reusing, as you already mentioned, you can change them and then version them just the same as you would as any other software library. So let's say that our site reliability team came along and said, you know what, I don't think one replica is enough for a production ready application. We should probably make it 5. And then also, within your NGINX Ingress controller, you have all these advanced configuration annotations that you want to add that will really help you kind of create, production-ready applications. A great example of this is this annotation which forces you to actually redirect all HTTP to HTTPS. That's a really good mechanism within your production-ready application. So what we probably want to do is enforce this downstream for all our users. So what you would do in this situation is something like this. Let's do some coding together. So I'm going to go to my application, and I know that on my Ingress object, I want to add a new annotation within the annotations block here. That is something, oh, that's not what I want. I want to copy and paste this, like so. So let's say that we want to make sure that everybody that is actually going to deploy our, use our production-ready application, we're going to make them redirect all requests to HTTPS rather than HTTP. Again, a really good best practice. And if you think about how that would look in YAML, I would have to go and update all of my different definitions to add this annotation manually, or I would have to update my template, and could be a potentially really painful operation. But with Pulumi, all I had to do is add it to my production component. And at this point, you might release a new version, release version 1.0 or version 2.0 of your actual library. And again, let's not forget, we also updated the number of replicas, and we have enforced this new annotation for all of the different, all the different users. And so now, everybody who is using my kind of Pulumi component can rerun. They would update their dependencies. They would rerun a Pulumi up. And you can see that there's differences now in the actual deployment. So let's look at the details here, and you can see our annotation is getting added to all of our Ingress objects, and the number of replicas that's going to change as well. So I should be able to rerun this program, and it will update all of my downstream dependencies.
So
just a much nicer mechanism.
Really is we actually can version our infrastructure in this construct. Like we could actually have a change log that is we changed this annotation and we changed our replicas.
Yeah. And
then you've got a point in time, you know when that change was applied.
Yeah.
Just like software.
Yeah. And you could, like, you know, if your information security team comes along and they notice the, you know, NGINX Ingress controller can enable something like HSTS, which again, really useful for your production ready application. Some of your applications might not be ready for this, right? Like some of them might not be ready for HSTS to be used. They can use older versions of the library, and all of the ones that are ready to actually kind of, you know, use some of the security features that NGINX Ingress controller allows you to use. They can update their libraries as needed, and things can just get a much, you know, you can kind of pick and choose and version your infrastructure in that way. And, you know, they can kind of opt in or opt out and all that kind of stuff. This, for me, is one of the key kind of things about infrastructure as software. Being able to kind of, you know, release things reliably, take advantage of all these amazing features that are inside these kind of, you know, well put together pieces of software like NGINX Ingress controller, but being able to do it in ways that you already know within your organization. You know, and for me at least, you know, being able to do it in this Python language, you know, if you're a Python user, you might be looking at this and thinking that doesn't really look like Python to me, and it's because of the type system as well that we've added. But you know, like you're able to actually take advantage of all of the benefits of the languages that you're using. And we've obviously talked about Python today, but if you recall back to my slides earlier, there's just so many different languages and different possibilities for you to kind of take advantage of. One thing that I think is I would love to have had time to show, but you know, we may have to do in a future live stream. One of the really amazing things about Pulumi is I can write this production-ready application in my Python language, but I can then create actual reusable interfaces in all of Pulumi's supported languages. I haven't done it for this particular demo, but it is possible for you to write a Python component or write a Go component or a TypeScript component, and all of the different languages that Pulumi supports can consume those components. It's magical. I don't even fully understand how it works, and I've worked here a year. It's an incredible piece of technology, but you know, it's a really powerful mechanism and allows you to get the ingress objects and get the ingress controller into the hands of people within your organization really, really easily and in ways that they understand. So that's all for my demo today. I hope that kind of excited a lot of people. I've seen a bunch of questions coming into the chat. Should we take a look at them?
Yeah, absolutely. Thanks to Paul Stack from Pulumi, who's helping us out with answering some, and our Jason Schmidt from NGINX, who's also answering some on the fly. So a couple that I captured kind of on the fly. Somebody asked about, can it convert JavaScript code to Kubernetes YAML files, or are we having to use the Pulumi platform? So I think it's an understanding of that.
Yes, so we have this option on the Pulumi provider, and I'm just going to quickly bring it up and then put it on the screen share. What you can do is you can actually render the Pulumi YAML from your language. You can actually render it from Pulumi. So if you just bring up the kind of screen share again, you should be able to see that we have this blog post here where you set this render YAML to directory flag. This is in TypeScript. This is available in all of our languages. And what ends up happening is it ends up creating actual YAML manifest for you. So if you are using another kind of deployment tool like Argo CD or Flux, Pulumi is completely interoperable with those. So, you know, if you kind of want to keep the kubectl apply deployments from before, you can render that YAML just by setting what we call a provider flag here. And it's totally possible to kind of just do it straight from there.
Awesome. And I don't know if this question is applicable about NGINX integrating in this sense with service mesh, or is that maybe off topic for this call? Somebody asked about that.
Yeah, I think let's go to the other questions.
Okay, I wasn't
There's
sure.
a lot
Yeah.
of service mesh material on our website that can go
Okay.
into details on it.
Okay. Why would somebody mention? I think Jason's answering right now about why would anyone add Pulumi to a Kubernetes stack when we have Helm or other tools already? So I think you sort of answered that. And
That's a great question. I have a bit of an answer, and then I want to hear Lee's answer. But for me as a user and an engineer, kind of at a high level, I can define my cloud infrastructure in Python, right? Like I can define all my AWS concepts, all of my AWS or Azure or GCP or even vSphere, right? I can work on all of that within the same Python code. I'm writing code to define infrastructure.
Yeah.
And then at the next layer of abstraction, once that infrastructure is defined and I've added a Kubernetes cluster, it's the same code. I'm still writing Python to define that infrastructure, right? And then if I need to integrate with third-party systems, internal ticketing systems, or bring in libraries or any other additional help, that's all within that same ecosystem. So before I was, as an application developer, writing application code and thinking in code, like that's my world. But now I can bring that same mindset to the entire infrastructure stack. Helm is awesome, but now I don't need to learn another DSL, domain-specific language, just for Helm, or Kubernetes YAML, or AWS's proprietary APIs, right? It's all accessible to me from within a Python API or TypeScript or .NET, etc. And I want to hear what Lee has to say about this.
Yeah, I think you did a really, honestly, I think that you kind of really touched on all of the points that I think are really, really important. But I think there's additional things around, if you think about the user interface, and I'm really passionate about user interfaces. I think that's such an important part of our kind of technology language. And I think sometimes the user interfaces are barriers to entry for people. Like I've used a variety of different infrastructure tools. I've used a variety of different mechanisms for actually getting things into production in my career. And one of the things that I've always felt is that once I started actually asking the developers that I work with, hey, I'd like you to help me, right? Like I don't want to be the single-handed person doing all of the production deployments anymore. The single barriers to entry that I always found was like, well, I already know Java, I already know Python, I already know Go, I'm already a software engineer. Why are you making me learn and read this document with all these configuration language, like these configuration options? I mean, again, if you look at the kind of configuration options that are offered via annotations with NGINX Ingress controller, like I love reading pages like this, but not everybody does. It's not an enjoyable pastime, especially when you're software engineers. They already have a bunch of like open issues and bug fixes and things that they've got to get out of the door. And I think what's really, really important for me is that Helm, if your job is to deploy things and it's not to kind of write software features, Helm is great for people like in those situations where you can go and read all of the different parts of it. But then when you actually try and get it into the hands of people who just want to help you get things into production from a software development lifecycle perspective, it's really, really difficult for them. Like you're asking them to do two jobs, and being able to use the languages that Pulumi provides you, it's like, it's imagine if you had to learn a whole new job and then they told you, by the way, you also have to learn French at the same time and you don't know French, like you're making it infinitely harder by giving more variables to the equation, right? Whereas if you said, hey, you're going to have to learn how to deploy things to Kubernetes and we're going to let you do it in English as well. Like, if you think about it from that perspective, it's just a way more user-friendly mechanism. Another thing that we actually got a tweet a couple of weeks ago from somebody who is a software engineer and is visually impaired. And I was really, really happy to hear that Pulumi has completely changed their lives, because if you're visually impaired, as an example, YAML is really, really difficult, right? Like you don't have any kind of like screen reader support and help. Whereas with software engineering languages, you do get those kind of things. And when you think about it from that perspective, that applies to everybody every single day. Being able to actually deploy things in languages that make sense to you, and really, I think is a different way of thinking about things. And for me as an infrastructure background, I think that all the things that come with NGINX Ingress controller kind of really make your application bulletproof, make it ready for production. But my software engineers that I'm servicing, they don't really care about the underneath. They just want to get it into the, they just want to finish their work for the day and kind of move on to the next bug fix or the next feature request.
Removing that layer of complexity. Lee, what about declarative versus imperative? Is Pulumi which is it?
So Pulumi is declarative.
Okay.
So we allow you to use imperative languages, but the actual end state is declarative. So Paul is actually really helpfully answering a question right now. Yeah. You can actually define your code using loops and if statements, but what actually happens within the Pulumi engine is that that code is translated over protocol buffers, gRPC, all these fancy technologies that I don't really understand. What actually ends up happening in the Pulumi engine is that Pulumi then goes and derives to a desired state. And so it's kind of an interesting thought process when you think about it. Like I can do an if statement and it's kind of read by the Pulumi command line interface, gets past the internal Pulumi engine, and the Pulumi engine it reads your code and then figures out what your actual end state should look like. What your end state should look like, which means that you can do things like for loops and all that kind of stuff, and use all of the things that you're used to in your kind of already in Python. You can use all these different things, but the actual desired end state is always declarative. And there's a big misconception, I think. I was having a conversation with somebody on Twitter yesterday. I was like, there's no way that Pulumi can be declarative. It is. Like it's the way that the Pulumi engine is defined is declarative.
And this is really, really useful. I want to highlight that when you have defined what state you want it to be, it is a lot more easy to reason about. I've written code using some of these open cloud APIs and so on, where it is fully imperative. You are programming cloud infrastructure, but it's all imperative. And when you have a failure, you're on your own to deal with that. You have timeouts, you're on your own to deal with it. You've got dependent infrastructure you need to chain together. Multi-cloud, same problem. It's like having the declarative model where you say what you want it to be and then either pass or fail or omit warnings is so much easier from a programming standpoint. It may not seem like that initially, but it's once you actually get into that coal face of being there, doing it, using it in anger, that you really experience how valuable that is.
Awesome. Well, we've only got a few minutes left. I thought I would do some what I caught from the key learnings of this, and then we'll get some contact information up there. So if people have more questions, and we'd also like to mention we're gonna do a version 2 of this coming up. So I think what I learned today was that of course the NGINX Ingress controller is a best-in-class traffic management tool, but it's got tons of features and capabilities that Pulumi can take advantage of. And I love the infrastructure as a software that Lee mentioned. A lot of different options. It's very flexible, but I'm building my own platform, and by doing that, I'm avoiding the sprawl. Although YAML's a possibility, but too much configuration. Pulumi is providing that language that I understand as I'm building these applications. And what that gives me is maybe less mistakes, but more importantly, probably faster production, especially with versioning. And I'm going to walk away with that confidence in my deployments. And it's also going to make me release things that are more reliable. And that bridge between NGINX, the Ingress features, Lee emphasized, I think was really important. So, I think we'll all agree that the Pulumi NGINX combination is super powerful, defining those configurations and the infrastructures within Kubernetes, standing it up, applying all those resources. And I think that's awesome because it's going to let us build those custom images and deploy them faster in our cluster in a really super easy way. So excellent stuff, gentlemen. I really appreciate it. Some great questions. We appreciate everybody's time and efforts here. If you'll see on the screen there how to reach out to Lee and I think we'll put Elijah's up there too if we haven't already. Yeah, they'd love to hear from you if you have some more questions, and please keep your eyes out. We're going to do a version 2 of this. We'll go a little deeper, as Lee and Elijah mentioned.
Well,
parting thoughts, guys. Lee, Elijah.
Elijah, go ahead.
Yeah, so I want to pitch the V2 a bit here. So what we have in flight, and Jason mentioned it in the comments, is we're working at building out a reference architecture that illustrates the whole process of setting up your AWS infrastructure, your VPCs, EKS, and your application in Kubernetes with FileBeat, Elastic, and metrics collection. And we're going to keep adding more and more of these kind of productionized features and showing how that all works together using Pulumi and NGINX technologies.
Awesome.
There should be a link to that in the comments. We're doing all of the development out in the public, so you can see where we are right now. Right now, we have a working example that you can download and try for yourself.
Awesome.
Yeah, kind of echoing just right at the end here, like Elijah and I have been working together for a little while now on kind of this reference architecture. It's been a really great experience. I'm really excited to show everybody all, and we hope to see you back here for the next session where we can show you even more powerful combinations of Pulumi and NGINX together.
Awesome. Thanks again, gentlemen.
Thanks, everybody. Have a great rest of your day.
Thank you.